start our sixth lecture. In the fifth lecture, we have already mentioned that when we find the critical path, you can find the critical path using the basic norms of finding all the path and collect the duration of the completion of all the paths, and the maximum values should select as the critical path, and the corresponding activity is known as the critical activity. But there is some big problem, because if the network has too many paths, in that case your construction time and duration or the find the critical path is so many complicated. Exactly for that reason, here we use the concept of structure to find the two different approaches. Here we mention these two different approaches for you. One is here, and the CP means the critical path calculation involve two passes. We have already mentioned in the last lecture. One is called to determine the earliest occurrence, and it's represented by EO, capital EO, the name of earliest and occurrence. So it is known as EO time of the event. It is called the forward pass method, and the computation start for the node 1 and advance recursively to the last node n. Initially we consider the set EO1 is equals to 0, as the start time of the project is 0, because when you start a project its time becomes 0. Next, general step to determine the EOs, and the first step is you should consider separately each node, say I, from where an activity is directly converging and into the node J. It means you have to calculate your result from the starting node to the particular node where you want to find the earliest occurrence time. Okay, next one. The next step is move to the next slide and clear everything. And the second case is, the next step is this one. Next step is this: add earliest occurrence EI and corresponding activities time DIJ. Okay, we should clear everything with a, for example, select the maximum of them as EO of J, the earliest occurrence of, which always consider the maximum, that is the forward pass completion of any earliest occurrence of a node n is computed. Similarly, we consider another concept is to determine the latest occurrence LO time of the event, or the computational start at the last node n and end at the node 1. When we start the forward pass algorithm, in that case you have to start from the initial node. When we calculate the backward pass, you have to start with your end node. If it's a network diagram, the starting node is called the source, end node is called the sink, start or so end, and too many names are there. Too many names are there in the network analysis. Backward pass start after the forward pass is completed. If you cannot complete your forward pass, then you should not start your backward pass. Okay, initial step, it's the calculation of the latest occurrence in O of the node n equals to the earliest occurrence of n, because if you do not calculate the earliest occurrence, in that case you cannot calculate the latest occurrence n. Okay, as acceptable the project delay is 0, আমরা ধরে নেব যে প্রজেক্টের ডিলে হয়নি। General step to determine the LO, consider separately in each node, say J, to which an activity is directly reaching from the node endpoint node থেকে and subtract the activity time tij from the corresponding latest occurrence of j, select the minimum of them as elo। মানে যতগুলো পাথ হতে পারে তার ভেতরে সবচেয়ে কম টাইম ডিউরেশন যেটা সেটাই হবে তার লেটেস্ট অকারেন্স। ওকে, clear? And here is another very important is the backward pass is completed when elo is completed. Okay, and event j will be critical, it's very important. We have already mentioned which event should be the critical event if its earliest occurrence time and the latest occurrence time be same, otherwise it should not be the critical activity. Okay, so an activity ij will be the critical if satisfy the following three conditions. First one is the earliest occurrence should be equals to the latest occurrence. Earliest occurrence of j is the latest occurrence of j, and latest occurrence of j minus latest occurrence of I, that should be equals to earliest occurrence of j minus earliest occurrence of I, that should be the time duration dij, otherwise the activity is a non-critical activity. If the activity is not a critical activity, we mention it as a non-critical activity. For an activity ij, l O latest occurrence of latest occurrence of the node j minus earliest occurrence of the node I has the maximum span during which the activity may be scheduled. That means it's represent আমি প্রথমে latest occurrence time duration টা বার করব, earliest occurrence duration বার করব, এদের যে ডিফারেন্স এটা রিপ্রেজেন্ট করে the maximum span during which the activity may be scheduled, মানে এই ডিউরেশনের ভেতরে অন্য ম্যাক্সিমাম অ্যাক্টিভিটি স্পেন্ড করা যেতে পারে। Exactly using this concept, every concept, we move to the next example to find the critical part using forward pass and backward pass method. Okay, so move to our next page. This one, you have to find, determine the critical path for the activity data given below, all the duration of this, and here we mention, exactly here we mention the initial node and final node, and that means initial and final node is given, you just construct the network, and the duration of the node initial to final node is given here 5 days. And I'm not mentioning how can I construct the network because you have already learned everything in our previous lecture about the construction of the network diagram. So here we concentrate to find the forward pass and backward pass, nothing more. So we are not interested to the construction of the network diagram. If we can construct this network, then how can I find the forward pass and backward pass, this one. Okay, so here according to the concept of this, you start with e, here it's mentioned e o, earliest occurrence of 1 is the starting node, that should be equals to 0. So here we mention this 0. Okay, next we find the earliest occurrence of 2. In that case you have to add 0 earliest occurrence. How can I find the earliest occurrence of, exactly we use this procedure, earliest occurrence of 2, earliest occurrence of 2, that should be equals to the just previous earliest occurrence of 1, earliest occurrence of 1, earliest occurrence of 1 plus the duration of the project, is represented by T1 2. Okay, sorry. So the earliest occurrence of the calculation of the point 2 is earliest occurrence of the point 2 should be 0, that should be 0, and that is 0, and this one is 5. Exactly for that reason the result becomes 0 plus 5. So the result here is 5. Okay, then how can I find the earliest occurrence of 3? Earliest occurrence of 3, earliest occurrence of the point 3. How can I calculate? You can calculate in the two different approach. One is from, you can move from 1 to 3 directly. In that case it should be 0 plus 6 is a path, another path is, and the another path is, this one is 5 plus of 3, that is 8. Okay, sorry, this one mentioned the forward pass, this one mentioned the forward pass, I am wrongly written this one becomes the maximum of, you should consider this one should be the maximum of 0 plus 6 and 5 plus 3, 5 plus 3. So the maximum value is 8, maximum value is 8, so the earliest occurrence of the point 3 is 8. Similarly, we calculate the earliest occurrence of 4. It's the direct path. 5 plus 8, that is 13, so nothing to worry about that. Okay, when we calculate the earliest occurrence of 5, in that case that should be 8 plus of 2 10, and for this case 13 plus of 0 13. We should consider the maximum value, so here we consider the 13. Next, when we calculate the maximum earliest occurrence of 6 or the point 6, that should be calculated from this way, that should be calculated from this way, and this way you have to collect the maximum value. From this way that should be 13 plus of 2 25, from this way that should be 8 plus of 11 19, and from this way that should be 13 plus of 1 14. The maximum value is 13 plus 12 25, so here we consider 25 is the earliest occurrence of the point 6. Okay, next we move to find the latest occurrence of or the backward pass calculation. Wait for the next lecture. In the next lecture you should learn this lecture. After listening this lecture, you have to move in the lecture number 7, which is to procedure to evaluate the backward pass method and how can I calculate the critical part. Okay, thank you.